Hi, my name is Julieta Diaz and I am a data scientist at TIBCO. Welcome to this Team Studio Enablement video. In this video, I will cover the random forest operator. We are starting from the Workfiles tab in a workspace I've previously created, and we will click on the random forest workflow to get to the workflow canvas you can see here. Random forests are ensembles of decision trees. This algorithm combines many decision trees in order to reduce the risk of overfitting. The random element has to do with the way the data is fed to each of the different trees, and the forest has to do with the fact that we are dealing with a number of different trees to create this type of model. I'm going to show you exactly how to configure a random forest in Team Studio. But let me first explain to you this workflow. We have the famous iris dataset here. The iris dataset includes 3 iris species with 50 samples each. And it is composed of 5 columns, 4 columns of measures on the sepal and pearl, and the column containing the labels, setosa, versicolor, and virginica. What we are doing here is the typical modeling process where we split the dataset in training and testing. The next step is to create a model and assess how well it does. This is a classification problem, so we are going to use the random forest classification operator. But there is another random forest operator you can use when you are trying to solve a regression problem as well. So let's drag the random forest classification operator into the canvas, connect it to the training set, and see what we need to configure in this operator. If you look at the operator itself, we can see that the first thing we need to specify is the dependent variable, which is species in this case. And we also need to specify the independent columns. When you set this parameter to yes, the operator uses all the available columns as predictors and ignores the continuous and categorical predictors parameters. When you set it to no, you will then must select at least one of the continuous or categorical predictors. In this case, I will select to use all the available columns as predictors. There are many other parameters that you can configure for this operator. The impurity is a measure of the quality of the labels at a node. A node is considered pure if it contains only a single label. There are several indices to measure the degree of impurity. Team Studio provides 2, the Gini impurity and the entropy. The following parameter lets you define the metric for measuring the model performance during the cross-validation training. In classification, accuracy is a commonly used metric. It represents the fraction of correct predictions. But, depending on the problem, you might want to select the F measure. Another parameter that you will be able to change is the number of feature functions, which refers to the function to determine the number of features for building each decision tree. In Team Studio, there are a couple of options available, so you could either specify square root, which is the default function. That means that the square root of the number of columns gets created for each decision tree. You can specify a third or the log function as well. You can have all, or you can explicitly define the function yourself. In this case, I'm going to leave this set square root as per default. The feature sampling ratio refers to the fraction of the number of features per node to use when the number of feature functions is set to the user-defined option. The max depth is the measure of how much farther the tree has to be expanded down to each node until we get to the leaf node. Generally, in a tree-based algorithm, the more the depth, the more the chance that it overfits the data. Since random forest combines several different trees together, it is generally accepted to have deep trees. Bear in mind that the values of the hyperparameters should be separated in commas, as you can see in this default value here. The number of trees refers to the number of trees in the forest. The default values in Team Studio are 10 and 100. You can change these values. Increasing the number of trees can help with getting better accuracy, but there is a bit of a trade-off because you're increasing the amount of computation. The following parameter is a raw sampling ratio, which indicates the fraction of training data for building each decision tree. Then the minimum leaf size just refers to what is the minimum amount of samples allowed in a leaf node of a decision tree. The default value is set to 1. The max bin parameter indicates the maximum number of bins used for discretizing and splitting the numerical variables. This parameter should be larger than the number of unique levels of any selected categorical columns. And finally, we have the random seed and the number of cross-validation faults. This last parameter indicates the number of sets in which the training set is going to be partitioned in order to perform the CV method. I'm going to press OK and show you what the output of the operator looks like when everything has defaulted. The first thing that you get back is the parameter summary info, which displays information about the input parameters and the current settings. You also get the variable importance ranking. This is typical with random forest. You get a good overview of which of the different features are most helpful for classifying. And finally, the training summary displays a table with a row for each tested combination of hyperparameters. For each hyperparameter, we can see the value of the accuracy and which is the best model based on this metric. We can use the confusion matrix to assess the model's accuracy for each of the possible class values. We will drag the confusion matrix operator into the canvas and connect it with the model and the testing dataset. So, if I run the workflow again, when the analytic flow has finished, we can then look at the confusion matrix and see information about the actual versus predicted accounts of the classification model. For example, in this case, we see that the classifier gave us an accuracy of 0.9 for the Virginica label. One thing to mention is that in this operator and any of the operators, if you would like to know more about the different parameters and how they actually work, you just need to select this little question mark here on the top right-hand side, and it will take you straight to TIBCO documentation on the operator. Now, we are going to quickly have a look at the random forest regression operator properties. As you can see, it contains exactly the same parameters as the classification one. The only difference is the evaluation metric you can use. Between the options, we have the mean absolute error, the mean square error, and others. Thank you for watching.